All right, welcome to another WebAssign discussion. In this video, we're looking at section 8.1 on arc length. So arc length of a function, I believe, specifically. The basic idea here is you've got these expressions for your integral, right? You want square root of 1 plus f prime squared. So here you got to set up a do not evaluate. That's very nice because oftentimes whenever you're computing these arcs, their integrals are atrocious to compute. So if you want to set it up, you need square root of 1 plus f prime squared. Well, if f is 4x plus 3, you take f prime, 12x squared, you square that, you get 144x to the fourth. And so here you'd have square root of 1 plus 144 x to the fourth dx. That would be your result. Right, set up a do not evaluate. Hey, nice. So take the derivative. This is what, 1 minus 3 over x. 1 minus 3 over x would be quantity squared. You'd have to add 1 to it and put it in a square root. But you're essentially just following the recipe here to set up a don't evaluate. Hey, geez, another setup but don't evaluate. Life is good here. So differentiate, you get what, 6 cosine y, you square that, you get 36 cosine squared. Put that 36 cosine squared, add a 1 to it, and put it inside a square root. That is the recipe here. So set up an integral that could be used to find the exact value, okay? This one actually is not too bad. When you have x to the 3 halves, that works out pretty nicely. So the derivative here is just going to be x to the 1 half. And then whenever you square x to the 1 half, you'll get x to the 1. So you'll have square root of 1 plus x to the 1, and then, or just 1 plus x, right? And then the integral here is going to be between 0 and 4, because those are our bounds. Well, or whatever the bound you have is given, because that red number means you could be given anything as your top bound. But yeah, when you have square root of 1 plus x, that's just going to be a u sub where u is 1 plus x. Fortunately, dx is du, and then yeah, you just have essentially u to the 1 half that you're integrating, which would give you what, 2/3 u to the 3 halves. So that's not too bad. And then you plug in the top bound, plug in the bottom bound, and subtract. Nothing too wild or crazy. This is a classic example, because when you take the derivative of ln secant, you get 1 over secant times the derivative of secant, which is secant tangent. So then you end up with just the tangent function as your y prime. When you square the tangent function, you get 1 plus tan squared. Well, when you square the tangent function, you get tan squared. When you put that square of the derivative, namely tan squared, into the arc length formula, you'll get square root of 1 plus tan squared. But 1 plus tan squared is just the secant function, and the integral of secant function is known. You might have to like Google what the integral of the secant function is. Integral of secant x. I think it's ln. Yeah, no, that's the question. Oh yeah, ln secant x plus tangent x plus c. So that's just a formula to have sort of in your back pocket when working WebAssign exercises. But yeah, if you integrate the secant function, ln secant x plus tangent x, life will be good there. Follow that recipe for that capital F function, plug in the top bound, plug in the bottom bound, life is good. Right, if the function's continuous and f of 0 is 0 and f of 3 is 4, then the arc length of the curve is at least 5. Well, think about this. The shortest the arc could be is a straight line. And a straight line would go 3 units horizontally and 4 units vertically. Now, 3 units horizontally and 4 units vertically, because we changed 3 in x and we changed 4 in y, would give you a straight line distance down that hypotenuse of 5. So if that curve is anything other than a straight line, it went further than 5 units, right? The shortest distance between 2 points is a straight line. That's essentially what this is saying. So at least 5, yes, true. That is absolutely true. 5 at a minimum, definitely no less. By virtue of the continuity, right? The continuity is important here because, well, you'd have to not pick up your pencil going from 0, 0 to 3, 4. Determine whether the statement is true or false. If f is less than or equal to g, then the arc length, oh no, that has nothing to do with it, right? I mean, g could be greater, but be just a flat horizontal line and be having the shortest possible arc length, where f could be lesser and just bouncing up and down and up and down and up and down and have this incredibly long arc length. So, yeah, that's totally false. Well, the arc lengths of this and this are equal, yeah, sure, of course, because if all you do is shift the function up, it still takes just as much pen ink to draw the two functions. It's just one is drawn higher, right? I mean, this is just a vertical shift. That's not going to change the length of the arc. It's just going to change, it's just going to shift your picture. That's actually a pretty nice question. The length of the curve, this is given by that. I wish, right? Because the arc length formula is 1 plus f prime squared, not f squared. So f squared would be x to the sixth, but f prime squared would be like 9x, well, 9x to the fourth, right? Because 3x squared times itself. So yeah, just got to be careful about that with what your formula is. But gosh, you ought to know your formula because you just hammered out like 4 or 5 with the formulas right from the get-go. So hey, not too bad on the arc length. Hopefully this was helpful. And well, that's that.